Okay, I haven't shrunk, but I did zoom back a little bit so I could get all of this stuff on the camera. Because we want to refer to how this compares with this. So what we do is we replace this function with a function that's identical, and it's a little hard to read. This says x minus 3 quantity squared. All this is then is, let's see, I think I've got everything. Anyhow, it's the same as this function, except I've got a square here. Now, what does that do to the graph? Well, the zeros are still going to be at the same place. I think you can easily verify that. The y-intercept, well, f of 0 gives you the y-intercept. The only difference in our calculation, over here we did 0 minus 1, 0 plus 4, 0 minus 3. Over here we're going to do 0 minus 1, 0 plus 4, 0 minus 3, because those are the factors we have, except that the 0 minus 3 will be squared because the x minus 3 is squared. Okay? Now, I'm not sure that square is completely showing up on this camera. So I think, well, there, I'm sure it is. Okay. Still hard to read. X minus 3 quantity squared. Okay, well, when we evaluate, then we got to square this. Now, 0 minus 3 was negative. So when we multiplied over here by 0 minus 3, it changed the sign of this product. Of course, this product is negative 4, right? So we'd have negative 4 times negative 3 is 12. Now, the product of these two numbers is still negative 4, but we've got to multiply by the square of negative 3. And the square of negative 3 is 9. So we have negative 4 times 9 gives us negative 36. That changes the sign of our y-intercept. It was positive here, but since the 0 minus 3, which is now squared, was negative, squaring it changes the sign. You think through that, but you can certainly verify that it's so. So on our graph, we have 0 here, a 0 here, a 0 here, and a y-intercept down here. Now, when I ask people to draw a smooth curve through these points, they did the natural thing because they didn't know how to anticipate this, so they didn't do anything wrong, but they got a graph. Well, they got this white graph. It came down here, came through here, came down here, so it's going to do this and this, we think. Well, there's a problem with that, and that is because if x equals negative 10, the y value is going to be positive. Because if x is negative 10, we've got a negative here, a negative here, and the square of a negative here. Now before we just had a negative, and a negative, gave us a negative result. Now we have a negative and a negative, which gives us a positive, times the square of a negative, which is positive, and we get a positive number. On the right, we naturally, all the numbers are positive, so it's going to come out positive, okay? So how can that be? The graph can't be the white graph. So I say can't be right because, I don't have an S in my because, now I've got a bad looking S. Okay, because why? Because, arrow, this doesn't happen. It can't do this if you're going to end up with a big positive number over here. I mean, this is clearly positive. This is the last chance you have to go through the x-axis. These are the only zeros. It can't go through this way because it's got to be a big positive number by the time you get out to x equals 10, just a little further along. Okay? But of course, it can't go through the x-axis between these two zeros, and it has to go through this point down here between these 2 points. So the graph has to do this, and it has to be a big positive number when x is negative 10, so this part of the graph looks pretty much okay. What doesn't look okay is this. So it turns out that what happens is the graph does something that nobody would have anticipated until they've seen this. The graph can do this. Come down through here, it can go up through here, then it can come down here and turn around just as it touches the x-axis at the point 30, because it has to be 0 at this point. And then at that point just turns around and goes back up, just like a parabola might. Okay? Now there'd be another possibility. It could have come down here and come up to this point and turned around, and then come back up through this point, and it would still have been okay. So I'm going to kind of draw that graph and then talk about why that isn't what actually happens. Okay, so but it could have. It would have been consistent with all the information we have at this point for the graph to come down like this, go through here, come up to here and turn around, then turn around again and take off this way. That would have been consistent with everything that we know at this point, but it's inconsistent with a couple of properties of polynomials. And we can actually see by looking at this function that it's going to be this rather than this, okay? So I'm going to talk about how we distinguish between this behavior and this behavior just based on the formula for this function.